Hi, in this presentation, we're going to learn how to write formulas for piecewise functions. In this example, the question says, write a piecewise formula for each graph. So let's start with graph um, in example A. What we see is we have two line segments. One starts from x equals 1 and it stops at x equals how much is that 4. So from x equals 1 to x equals 4, that would be this segment over here. And we notice that the beginning of this segment there is an open circle, and the end of this segment there is a closed circle. Now the other segment, this one over here, it starts at x equals 0 and it stops at x equals 1. However, at x equals 0, we have an open circle. Okay. And the third one, which actually I'm missing something in here, so it is array. The first two are the line segments, but the third one is array because it has a beginning but no end. So it goes from 0 and extends to negative infinity. So 0 to negative infinity, 0 to negative infinity, or from negative infinity to 0. Okay, now how do we write a formula for this piecewise function? Okay, let's start with um, f of x. Let's label this function with f. So f in terms of x. So f of x equals. Now let's start with the blue segment, this segment over here. The best way to write a formula for a piecewise function is if you first write a condition. So the condition says, well, if x is smaller than or equal 0, because the 0 here is included, there's a closed circle in there. If x is smaller than or equal 0, then what is the equation of this array or uh, line? Well, line goes from negative infinity to positive infinity, so it's linear. It's a it's array. Okay, so what do we need to write an equation of a line? We need the slope and we need the y-intercept if we want to write it in slope-intercept form. So the slope is let's write m equals, so 1 down and 2 to the left. 1 down, that's negative 1. 2 to the left, that's negative 2. So it's 1 half. The negative cancels with the negative. So we know that the slope is 1 half. How about the y-intercept? Well, the y-intercept obviously is 0. So this equation would be uh, 1 half x plus 0, which we don't really have to write it down. So we're done with the first one. Let's do the second one. The second one, which is this one here, we said the it starts at 0 and it ends at 1, but 0 not included. So we say if um, 0 is less than x and x is less than or equal 1. It goes from 0 not included to 1 included. Then what is the equation of this line segment? Well, obviously we need the slope and the y-intercept. The slope, we got 2 down, so m equals 2 down is negative 2. 1 to the right, that's positive 1. Anything to the moves to the right, that's positive. To the left is negative. Down is negative. Up is positive. So 2 down, that's negative. 1 to the right, that's positive. So it's negative 2. So the slope is negative 2. Okay, so we got the slope. What is the y-intercept? Obviously, the y-intercept is 2. So in this case, the equation of this segment is negative 2x plus 2, mx plus b. M is negative 2, and b is the y-intercept, which is 2. So negative 2x plus 2. Let's do the third one. For the um, third one, it's a line segment again, but it's horizontal, constant. It starts at x equals 1, and it stops at x equals 4. So from x equals 1 to x equals 4. Okay. So the condition would be, of course, at x equals 1 is not included. So it's 1 less than x, and x is less than or equal 4. Now, this is a horizontal line, so its equation is straightforward. So y equals negative 1. So we just put negative 1. And this is the piecewise function for this graph. Let's do the next example, example B. So we notice in example B, we have three different pieces. Not four, sorry, four. So the first one, the orange one, that's a line segment. And the green one, the second piece, the green one, is another line segment. But the third one here is a half circle. And the fourth one is another line segment. So let's label this function with g. So g of x equals, and with the space for four expressions. Let's start with the orange one. So the orange one, um, it starts at x equals negative 4, and it ends at x equals negative 2. Now, this point is a common point between the orange line and the green, or the orange segment and the green segment. It's a common point. So we either include it with the orange segment or with the green segment, but not with both. So we decide which one we should include it with. So I'm going to go ahead and include it with the orange one, but you could include it with the green one. So condition is for the orange is if negative 4 is less than equal x, and x is less than or equal negative 2. What is the equation of this line? So I need the slope or the line segment. Um, I need the slope and the y-intercept. The slope m, let's count. I can go one down, one to the left. One down is negative 1, one to the left is negative 1. So the slope is 1. Okay, the slope is 1. All right. Now I have the slope is 1. What's the y-intercept? Well, there are two different ways how you can find, or you there are two different methods how you find the y-intercept. The easy one is you can track it through the graph. So here, if you move one forward and one upward, one forward, one upward, one forward, and one upward, connect, here is the y-intercept. Okay, one forward, one upward, forward, upward, here's the y-intercept. Okay, so I know the y-intercept is 5 in this case. So my equation of the line is mx plus b. M is 1 times x plus b, which is 5. Now, how about if we cannot track it graphically like I did? Okay, I want to show you what you can do instead. So what you can do is you can do you can use some algebra to find the y-intercept. So y equals mx plus b. I know that the slope is 1. So y equals 1 times x, which is x, plus b. Now you can pick a point on this line seg on this segment. Let's pick this point, for example. You can put any point you want as long as you know its exact x value and exact y value. So this point here, its x coordinate is negative 3, and its y coordinate is 2. So negative 3 and 2. That means 1y is 2, x is negative 3. That's what it means at this point. 1y is 2, x is negative 3. So you just solve. Add 3 to both sides. So that's 5. So either use algebra as I did over here, or you just track it graphically. I think it's easier to track it graphically, but if it's not possible, then use algebra. So now we're done with the first one. Let's move on to the second segment, which is the green one here. Um, so what is the condition? The green one goes from negative 2 to negative 1. Negative 1, we can include it, but negative 2 we cannot because we have already included negative 2 with the orange segment line. Okay, so we want to say if negative 2 is less than x, and x is less than or equal negative 1. Then what is the equation of the line? Okay, we do the same thing. Let's find first the slope. Let's find the slope. So the slope, if we go down 1, 2, 3, so m equals 3 down, that's negative 3. 1 to the right, that's positive 1, so it's negative 3. What's the y-intercept? Well, go down 3, 1 to the right. The y-intercept is negative 3. So you follow the same pattern pretty much. 3 down, 1 to the right, 3 down, 1 to the right, and the y-intercept b is negative 3. So the slope is negative 3 and the y-intercept is negative 3. So negative 3x minus 3. That's the equation of this segment. All right. Now, in regards to half circle, let's use that for this one. In regards to half a circle, what do we need for this equation of a half a circle? Well, we need some knowledge of course, of the uh, formula for the graph of a half circle. What is the center? If this was a full circle, what is the center? Its center is 1, 1. I mean, sorry, 0, 0. Center is 0, 0. What is the radius? Radius is 1. So center is 0, 0, and the radius is 1. So the formula would be, because the center is 0, 0, and the radius is 1, so radius is 1, you just square it. So 1 squared is 1. And then because the center is 0, 0, then you just have simply negative x squared, 1 minus x squared. But this half circle is below the x-axis, so you need the negative. You need to precede it with a negative. So negative square root of 1 minus x squared. What is the condition? Condition there is negative 1 is less than x, and x is less than or equal 1. It goes from negative 1 to 1. And negative 1 not included because I have included negative 1 with the green line segment. Okay. Now, let's work on the last part, which is the blue one. Okay, the blue one. The last line segment, it starts at negative 1, and it stops at, so it starts at negative 1 and it stops at 4. So from 1 to 4. Starts at 1 and it stops at 4. So we're going to say if 1 is less than x and x is less than or equal 4. So this is a line segment. So what do I need? I need the slope and the y-intercept. So the slope, m, equals 1 down, 2 to the right. 1 down is negative 1. 2 to the right is positive 2, so negative 1 half. So far I have negative 1 half x. What is the y-intercept? Well, if I start from this point, I go 2 to the left, 1 up. So I can do the same thing here, 2 to the left, 1 up. So here how I connect these points. Now I can see that it passes through 1 half. So for every 2 to the left, you go 1 up. It means for every 1 to the left, you go half up, upward. So 1 to the left, half upward. Okay, so 1 to the left, half upward. So it will be plus 1 half. And this is the formula for the piecewise function. I will elaborate a little bit more on the half circle. Okay, on the half circle, if this was a full circle, then the formula would be x squared plus y squared equals 1. Now, if I solve for y, isolate y, so I have y squared equals 1 minus x squared. And then, if I take the square root on both sides, so y equals 1 minus x squared. Now, the half that I keep is the lower half, the half below the x-axis. What we know about this half of the circle, is point, every point's y-coordinate is negative. Every point on this half circle, every y-coordinate of every point on this half circle is negative. Except the point on the x-axis, which will be 0, but every other point will be negative. However, this formula here generates only positive values of y. So to fix the problem, I have to precede it with a negative. And this would be a different way on how to figure out how to write the formula for half a circle. Thank you for watching.